Alright, so today we're looking at linear rates of change. We want to be able to identify increasing, decreasing, and constant rates of change. So that's our learning intention, to gain the knowledge of identifying rates of change. It's important that you're able to calculate the gradient and identify if the rate is increasing, decreasing, or if it's constant. Okay. So with linear function, if we have a line that's pointing up to the right corner or the first quadrant, we call it as an increasing rate of change, and that rate of change is a constant increasing rate. Yeah, the rate doesn't change anywhere along the line. So this is a constant increasing rate of change, and it's positive. If it's going down and pointing to the bottom of the fourth quadrant, then it's decreasing. The rate is still the same; it's still constant. Obviously, if we have a line that's flat and it doesn't move, then that's a constant rate of change. All right. So let's imagine if we got point A and point B. We got 1, 5 somewhere up here, and -3 to -5. If traveling from A to B, so this is my A point, here's my B point. If I'm traveling this way, obviously it's going to be decreasing. Okay, and we can do that with our formula. Traveling from A to B, so 5 minus -5, and 1 minus -3, so it becomes 10, 4, sorry, and that's obviously giving me 2 and 1/5, so 2.5. So in this situation, this is actually traveling from B to A. Yeah. So if traveling now the problem is that if we are going to do this that way, we always read left to right. Yeah. So by swapping the terms around, that won't change it. Yeah, you still get 2.5. So let's try. So we've got, sorry. Yeah. I use that point second. So I use that point first. Yeah, you still get a positive. Okay. So, but obviously it's going from this way. So if I flip it around, traveling from, sorry, left to right, traveling right to left. Well, this is just going to be the opposite way. Yep, so you just put a negative because we're going that way. Okay. So there are other ways that we can represent rates of change. We can do it with a travel graph. You may have seen this in earlier years. Obviously, if this axis determines the kilometers away from a location, and this axis determines time. So if the line is flat, yeah, so these are stationary, no one is moving, yeah. Obviously, if the line's going up like this, it's increasing, so increasing rate. The steeper the line, the faster they're traveling. So the steeper the line, the faster the object is traveling. If it's going down, it's decreasing, and it's the same thing. So if it was a rapid decrease, it's traveling faster. If it's more flatter, it's traveling slower. So this is a decrease, and this is a rapid decrease. So what happens if we're looking at curves? So obviously if the curve is going up to the right, we're talking about that's increasing. And if it's coming down to the left, it's decreasing. And if it stays at a point, we call that stationary. So this is increasing, and that's stationary at that point, sorry. And this is decreasing. So imagine we have this polynomial x minus 2, x minus 3. We want to describe the rate of change between -1 and 0. So plugging in -1, I get -1 times -1 minus 2 and -1 minus 3. I get y equals -12. And from 0, I should get 0. Alright, so what we're going to do is we're going to plug that into our formula. y2 minus y1 over x2 minus x1. So we've got -12 minus 0, -1 minus 0. So I get positive 12. So it means that from these 2 points, the curve is increasing. Okay, what about from 2 to 2.5? So once again, so I plug in 2 into my formula, well, that's going to be 0. And if I put 2.5, that's going to be -0.625. All right, calculate the gradient between these 2 points. So 0 minus 0.625 and 2 minus 2.5. So it's going to be 0.625 over -0.5 gives me -1.25. So it's, as a negative value, the curve is decreasing between these 2 points. So I've already got this y value. So if we're looking at 2.5 and 3, let's figure out what that's going to be 0. So we want to calculate these 2 points. So -0.625 minus 0, 2.5 minus 3, so -0.625 over -0.5, I get 1.25, so here the curve is increasing again. Alright, what about when x equals 2,549? So I'm going to plug that into this formula. So 2.549 times 2.549 minus 2 times 2.549 minus 3. Okay. And that's going to give me a negative value. All right. That just tells me the position of my point, not the gradient. Okay. So if I was to quickly do a sketch of this, I know that there's at some point there will be a stationary point, right? So I've got 0, 2, and 3, and I know it looks like this. So somewhere here and here there will be a stationary point where the rate of change will be 0. Yeah. And usually we will use calculus to find what is the exact point when the 2 points will be 0. If I moved closer, if I had, let's say, x equals 2.5, so one step away from that, so just a tiny, tiny step. So what's the gradient between those 2 points? So negative 0.625 minus negative 0.63 over 2.5 minus 2.549. What do we get? We get 0.1, which is very close to 1, so it looks like it's slowly decreasing from that point. Okay. It's almost from the stationary point, and it's that point where it's just coming down, slowly decreasing. Okay. So obviously we need to know what the difference between increasing and decreasing rates, especially when we're looking at different types of graphs, so travel graphs or curves or linear, and to see where it's constant. So something like this kind of curve, they might have a constant rate of change, but then here it might decrease really rapidly and then kind of slow down the decrease. Yeah, so it's just being aware of those things. Okay, good luck.